Hello, everyone. I'm Eli Plaskett, Senior Associate Editor with Modern Machine Shop. Welcome to today's presentation, Automatically Generate PPAP APQP Submission Requirements. The presentation will be led by HiQA Vice President of Business Development, Tim Hogan, who will introduce us to the topic. Tim has been in and around manufacturing for almost 30 years, having worked for Tier 1 and Tier 2 suppliers and one of the leading providers of quality control equipment. Tim has a unique perspective on the topic, having been on the shop floor, working on machines, and working in the quality lab, ranging from programming CMMs to working with customers on submission requirements. If you have any questions, type them in the question pane of the webinar interface. We'll do our best to answer all of them at the end of the presentation. We'll also be sending a link to a recording of the webinar in case you missed something or just want to revisit the topic. Now, with all of the housekeeping out of the way, let's get started.
All right. Well, thank you, Eli, and thank you, everyone, for joining us today. We at HiQA greatly appreciate not only the willingness to carve out time out of your busy day to try and improve, but you also chose to spend it with us. So we hope the next hour will be very informative for you. So our mission, vision, and values are listed here. But the one thing I'd like to point out to you is that many of the people at HiQA have previously worked in manufacturing. Yes, we are a software company, but we've also been in manufacturing for many years and have felt many of the pains that you do. For example, as Eli mentioned, I was a quality manager, a quality engineer, a gauge engineer, and a CMM programmer for a Tier 1 automotive company and had to compile those PPAPs myself. So while we don't claim to know your individual challenges, everyone's always a little unique, we do understand the overall issues in quality because we've lived them ourselves. So in today's webinar, we're going to introduce the concept of what we'll be addressing in this short PowerPoint, okay? Then we're going to spend the vast majority of our time together with a live presentation of the software itself and our PQP application. So we hope you don't mind, but we thought you might like to see the product in action and how it can actually streamline your process. So is 75% a realistic number? So we typically state that you can save 50% of your time. However, our customers do tell a different story. It's not uncommon for our customers to see a 75% time savings in compiling their submission requirements from whatever process they're using currently. And oh my gosh, we know we get acronymed to death in this industry. However, it's important to note that although there are different forms of terminology across the industries, many of the requirements are the same. A PFMEA is a PFMEA, whether it's part of a device master record or an AS9100 package. Whether you're in medical, aerospace, automotive, construction, or even defense, most industries have developed some type of quality system to address some, if not all, of the 18 elements, right? So, but why, the challenge always comes in, and the question we get asked is, why are these requirements, why do they take so long to put together? Why does it take so long to make a PPAP? And really because oftentimes the data for these requirements needs to be compiled from systems that are totally disjointed. You know, prints are ballooned in one software. You know, they're measured in a different software. The data is compiled in yet another software, or worse yet, is put on a PDF and it's manually transcribed over to like an Excel spreadsheet or something. SPC is calculated in yet another software. Gauges are tracked manually or in a standalone software package. And gauge R&Rs are calculated or compiled in yet another. On top of that, the process flow, the control plan, the PFMEA are typically manually generated in Excel. So now you can kind of understand why quality engineers and quality managers often refer to this as death by spreadsheet. Right? There are so many different forms and spreadsheets and documents and lists to maintain and track and coordinate. A lot of companies hire full-time employees whose only job it is to compile this submission documentation. And that's where high QA with our PQP application helps to streamline and automate your quality documentation process. So we do this by providing the tools to keep the digital thread intact and increase collaboration within your organization, okay? Or even outside your organization, really. Now, from the time you acquire the information from your customer, whether it's internal customer or external customer, the collaborative digital life cycle begins. Now, it starts with data from your customer, again, as we mentioned, but it's typically in like a 2D print or a 3D model format, right? So then you can actually start the planning phase, the phase on top there, where we can automatically balloon the drawing, extract the information from it, and then now you can assign different things to it, right? Create those inspection plans, assigning measurement methods, sampling rates, even special designators like critical characteristics. But on the production side, you can manage all the gauges in your facility. You can collect all that inspection data for both in-process checks and final inspection. We'll get to that in a little bit. And even provide real-time SPC data, okay, including notifications for out-of-tolerance conditions. And if a dimension's out of spec, it can, if you want, create a non-conformance report digitally. Now, once the plan is made and the data is acquired, that information can be used to automatically generate your full submission package. No more 20-tab Excel spreadsheets. It's all in the database. And that's right. HighQA is a database-driven solution. Everything that's done is live and real-time in the database. So we won't have time to get into this today, but where this can ultimately evolve to is collaborating with your suppliers, right? Imagine getting the submission information back from your suppliers digitally and having it sync right into your database as if you did the work yourself. Your suppliers would actually become an extension of your shop floor instead of an entirely different system or department to handle the supplier data, by itself. And they don't have, and by the way, your suppliers wouldn't have to have HighQA either. If they do, it'd be a click of a button to bring that data across. But if they don't, we also have a hub where they can upload all of their data to, and then it would still go into your database. So for you, it would be, for you as the buyer, let's call it, would be transparent whether they have HighQA or don't have HighQA. Just want to point out that we don't mandate people to have HighQA. But if you had that, imagine analyzing data from two different suppliers with the granularity down to the balloon dimension number. And you can do this before they even ship the parts. So you know what the parts look like, what the dimensions look like from the actual data from your supplier before they even ship. Supplier collaboration is really the ultimate goal, and it can be achieved efficiently and digitally with HighQA. Okay, before we hop in the software, wanted to let you know that Scott Boeing is joining us today. Now, Scott is our Director of Account Management, and his role at HighQA is to help all of our customers and make sure they are well taken care of. Okay, Scott's here to answer any questions that may pop up in the chat. As mentioned, we'll address them at the end, as Eli mentioned, but feel free to drop them in as we go through the hour. Okay, so let's hop in the software and show you how we can streamline your entire process. All right, so we are simply going to start from a drawing, and we're going to pull up a standard PDF. I always pull it up just to let you know that it actually is a PDF. It's not like a special print or anything else that we use. It's a standard regular PDF drawing, right? And it has some information over here that we'll get to, but simply we pull it in and then we go up and click on our auto balloon button right here. And we have some options here as well. We can go through multiple pages. We can turn off basic and reference dimensions. Let's do that. I can show you what that looks like. Also have different options here. But excuse me. One of our claims to fame is our OCR technology. we have arguably the fastest and most accurate OCR ballooning software on the market. It's very, very quick, as you'll see in just a minute. But more importantly, what we're doing is we're going to be pulling the information from it and populating it into the database. So that was about 20 seconds. I think it was 19 seconds or so that it took. What we did is we analyzed the print, we scanned it, we figured out what's a dimension, what's not, what's basic, because I turned off basic, right? And we omitted those. And at the same time, we've already extracted that information in that 20 seconds and populated it down into the database. You're actually looking at a table in the database from the dimension number to the drawing zones, right? So they haven't been identified yet, but we have a grid option. So it'll automatically populate the drawing zones, which is a requirement on many FAIs. What the requirement is, nominals, tolerances, all of that information has already been extracted and populated in the bill of characteristics, right? But when we start getting into our submission information and documentation, I want to point out something else to you as well. We can set up defaults in the system that help to populate our inspection plan, which will ultimately be transferred to our control plan, okay? What is that? Well, here's a sampling rate, for example. I have it set up on my system, and you can configure your system however you'd like to. That says, hey, if this is a measured dimension, make the sampling rate 1 every 20. And you can see that here. But if it's a attribute, like a thread gauge, snap gauge, something like that, make it 1 per lot. So those are just some defaults we can set in the system. But now we can build upon that and change any one that we would want, right? Let's say for this flatness, we don't want it at 1 per 20. We want it at maybe 1 per lot, hypothetically. Sure. And we hit save, and now that's changed at 1 per lot. So that information will be used a few different ways, okay? Or at least a couple different ways. One, it's going to develop the samples that we need for the when we acquire data, right? But it'll also be automatically transferred to our control plan. So we're populating our control plan already just by the click of a button for ballooning the print, right? So let's get into, before we get too deep into it, just want to show you a couple things, because we kind of started our grassroots, if you will, are in the ballooning technology. So we do have some neat characteristics that we have with that. And I'm going to briefly identify a couple of those as we go here. So you can see that when the information comes in, it's simply the whatever the name of the file was itself. But we can say that this is the part name. And all I did is box select that, and you can see it's updated over on the side here. I can say this is the part number, and it updates the part number over on the side. And even different size fonts like this is okay. We can say part rev, and then we'll see this change from A to B over here. So I don't have to type all this information in, which actually is usually less accurate because it allows for typos in the system. So we can automatically extract that information. We're using the OCR to our advantage, right? Or to your advantage. A couple things just to, again, very quickly highlight. For notes, notes are a manual process for us because it's not standard. It could be anywhere on the print and listed and labeled and in a box or outside of a box. So we do keep them as manual, but it's simply a matter of toggling this little balloon note and then just grabbing whatever note that you might have. And then it's defaults it to note on the side over here. And you can see that we're using the OCR to understand what the letters are in there and what the words are, right? And you can move these around. They have leader lines come out, all that good stuff. Okay, so there's some tools in there for that. Also, oh, by the way, notes, just so you're aware, it treats them as like a pass-fail in the, when we go to acquire data against it. So as soon as we balloon a note, there is a pass-fail. Okay. We do track material as well. So something that you may like as well. I'm going to balloon this material right here. And now you can see a couple things. I'm just going to box select this material right there. And you can see this already switched over to materials and processes, and now it's populated in here. Now, I'd say this is kind of neat because this is going to serve a few different purposes for us. And I'm going to, let's see, Modern Machine Shop 1, 2, 3, material code. Actually, I'm going to address the API later on, but you can add information in here if you would need to. Maybe you have a certain spec number that you're going to, you get it from a specific supplier. Sure. Most of our customers will upload a material cert. I have a sample one here I'm going to add to it. Okay. So now that I have that information in the database, it's always there. If you happen to be in the aerospace industry, this information will automatically be put on Form 2 of the AS9102 report, right? That's a standard report in our system. However, it will also be in our materials and processes section right up here. We can see that it's already listed here. And when we go to compile our submission information, it'll be automatically put in there for us because it's already in the database, right? So just a couple neat little things to point out there. And you'll see it as we go. Just a couple, again, very high level overview. We'll grab this dimension number 10 right here. Please note that we did disseminate this out into 3 different callouts, right? There's a diameter, there is a thread, and there is a position, and we did notate those in 3. And by the way, as a side note, if you wanted these to be individual numbers, we support that as well. Maybe you wanted this 10, 11, and 12. When we first click on auto balloon, we would have clicked on this button here that says split subcharacteristics, and it would have made these individual numbers. Okay, so we support that as well. But from a 4X standpoint, some of our customers want to have them all put in one to make the report a little tighter. Some of them want them broken out. Either way is totally fine. But right here, you can see they're together and they say 4X. If you wanted to break them out, we could hit multiply dimensions and it would multiply them out. And now there's 12 lines of data in the database as opposed to just the 3 compiled. Either way, we'll be looking for 12 different entries of data when we go to acquire the data, but it just more depends on how you want to see it on the report and in the bill of characteristics. Okay. Can you delete them, renumber them? Sure, you can delete dimensions out. If it happens to miss one, you can manually add them like this by using the little scissor icon. It always adds it to the end, but we have a super easy renumbering button here that just kind of renumbers things, puts it right back in line. So you can set it up however you'd like to, and then renumber it and have it completely go through. And we have different numbering options as well. It's going to default to left to right, top to bottom. We can go in like a circular pattern around views. That's the way I used to do it in automotive, view by view by view, and then clockwise around the view. We support those as well. Okay. But let's get into more of the submission information and documentation, right? So let's grab this 2-inch dimension here. So as noted, it's set at 1/20, right? And we can see right down here that we have it set up for a caliper check because we have some defaults in the system already, or I do on mine. And again, you can configure yours however you'd like to have this as what we call the gauge category. Now, this gauge category will streamline it when we go to acquire the data, but it will also be automatically transferred to our control plan as our measurement technique. So as we're putting things in here, it's going to automatically generate our submission documentation later on. But maybe this is a CTQ in the system as well. Okay, maybe this is a critical characteristic. I'm going to hit save. And now if I look right here in the bill of characteristics, what happened is that our designator now shows us a CTQ. But we also I have a rule on my system. And again, you can configure your rules however you'd like. That says if it's a CTQ, automatically change my sampling rate to be based on an AQL table instead of the default of 1/20. So it's just the idea that you can set up rules. So if one thing happens, make another thing happen in the system. I also have it set up just more of a visual advantage to say, hey, make it a square, not a circle. And you can make triangles and hexagons and oh gosh, I think we have 6 or 7 different shapes that you can make it. Okay. So, and that's just a visual cue, and that will carry over to our shop floor tool that I'll show you in just a little bit. All that information is transferred over. Speaking of gauges, though, we do have a full gauge management system right in here. It is part of the software, it's part of the core package. It's not like a separate module or anything else. And if we click on like this caliper, for example, you can have a picture of it here, just the main information, all the calibration information itself. And by the way, we have notifications for it. Again, this is more of like a high level overview of this to let you know it's available. Now, but why are we saying this? Why are we kind of giving you this overview? Because the important part about the whole ecosystem inside of high QA is that it's all interconnected. So as we're using a measurement tool, as we're defining something in the inspection plan, that information is used later on to generate our documentation. For example, we have as mentioned before, we have the gauge management system in the software itself. Therefore, whenever a measurement is made with that caliper, you have full exposure in the usage history tab as to every dimension that gauge has checked, right down to what it checked, the job, the lot, the sample number, if it was tied to an operation, which we're going to get to next, who measured it, the time and date stamp, if it was a non-conformance, all that information is in the database. So now we can start to make sense of it and kind of correlate it back and forth. We don't have all of these standalone systems. It's all cohesive in the same database and in the same system. It allows you to have a level of transparency to your, I don't want to say organization, but to your process, probably that you don't have today. So, okay, so that's on the gauges side. Do want to hop into the manufacturing operations because that's actually an important aspect of it. Because when you get this part, like, okay, I have this part, now I'm going to just jump in and it's going to poof, come out of a 5-axis machine and be done. Not really. It's going to have to go through operational steps, right? What happens in Op 10? What happens in Op 20, Op 30, Op 40, and so on and so forth. So typically, like in an ERP system or something like that, you would have the process or what features are being cut, milled, drilled, whatever, in that process, welded. So what features are associated with that process? What we're doing, or what we need to do here, is identify the dimensions that are affected in those different processes. And we do it very simply, right? You can do it a few different ways, and I'll show you what it looks like. If I click on this dimension, this dimension, this dimension, and this dimension, let's say we're going to rough this part out, for example. If I click on add operation right over here, and all I did was I was holding down control when I was selecting those. So it's very easy to do. If I click on add operation, now I have an op 10 with those 4 dimensions, but they all still need to be measured on the finished part, right? So that everything needs to be on the finished. But now within this op 10, I can say, well, maybe this, I think I called it a roughing op. So let's call this a roughing op. You can put additional information in here if you'd like to. Don't have to, totally up to you. But what it'll essentially do is allow you some additional fields in like custom reports. If you'd like to make a report for, hey, what's everything in the milling group? How did those parts run? So you can create some reports that way. But it'll also help populate our PFMEA and our control plan for, like the work cell and the group and the machine and things like that. So as you add information in here, it'll help to automatically populate our documentation later on. So, but I do want to pause here and mention the process because most of, as you well know, most of the documentation is built around a process, right? A process flow diagram, a PFMEA process. So what we've done here is what we haven't showed you yet anyway, is up in the manufacturing tab, we have what's called a process library. Now that library is going to house the information for those processes and the details for those processes. So now what we're doing is we're linking the process to the operation, right? So when we do that, it will automatically populate our process flow in our PFMEA when we go to generate our submission documentation. So this is an important step. It's crazy easy, but it's an important step. And again, all we're doing is tying a process to an operation. So I'll just come down here. I think I have a roughing process. Yeah, there it is. So I have a roughing process, and I'm just tying that to my roughing operation. And we can see that updated over on the side here. Now, just from a, to make our documentation look a little bit better next time, I'm going to add, or not next time, but in a few minutes, I'm just going to add some additional operations here and just label them something. And essentially what I'm trying to get at is, let's call this milling, is identifying the operation and then tying it to a process. So I'm just going to do that for all three of these. Let's call this a drilling op. Let's call this into the drilling process. And maybe we're going to finish turn this. We'll make it special. We'll say MMS finish turn. So you know it's the exact one that we're doing here. And we'll identify that with the turning process. So I always try to customize that so people don't think I'm, no smoke and mirrors going on here. So we have all of these identified. Okay, these are the different operations. These are the different processes associated with those operations. But now let's say we need to like to have something custom for a specific operation. Right down here in our bill of characteristics, you can see that we have finished part and we can see roughing right here. Well, if I just want to look at my roughing operation, I can, and I have unique dimension numbers and balloon numbers, if you will, for this specific operation. They're correlated with the finish dimension, yes, but their own unique balloon number, right, from a traceability standpoint. So speaking of traceability or user access, if you'd like to change things in just these operations, because that happens a lot. Like, hey, we have this op 10, but it's a different tolerance, it's a different nominal, it's different something. I want them to use a different measurement tool. We can see we're all listed here. We can say, okay, I want to update these, and we're just updating these unique ones. There are these unique dimensions for this operation. This happens to be in inches. Let's say you want to add 20 thousandths to the nominal. Okay, there you go. Maybe you want to leave it for finish later. Maybe you want to say, I want this to be plus 50 minus 40. Okay, maybe you want to identify it as a caliper. You could do that as well. And maybe you want them, maybe you have a new person on op 10 and you want them to measure at 100%. You could do that as well. If we hit apply and close, now we see for our op 10, they've all been adjusted by 20 thousandths. We're at plus 50 minus 40. You can see that right there. We're at 100% sampling rate. Now we didn't change the finish sampling rate, right? Those were still based on either AQL tables or 1 in 20 or whatever. But just the sampling rate for op 10 is now updated. Still have our CTQ, and now we're actually it was a caliper, that didn't change. But all that information has been applied just for op 10. Okay, so the idea is, okay, let's set up all of that information for each of those operations. Now we need to acquire the data against it, right? So now we're kind of set up. We have our information in the database, in the bill of characteristics. Now comes the transition point where we're like, okay, we have it set up. Now we're going to go make the parts, right? So when we go to make the parts, we're going to, we need a job in the system to be able to apply that against. Now, this is a great time to let you know that we have an open API. When that, essentially what that means is we can communicate to different software packages as well. Mainly like, well, not mainly that we can, but what it's mainly used for from our customers is like from an ERP system. Let's say you're using, SAP or Epicor or ProShop, something like that. You can populate this information automatically from that, so you don't have to type any of this information in. But even if you did, really the only thing we need are just a couple little bits of information there. You see the little red marks there. But also note, I have it selected here to auto default PQP documents. Let me show you what that's going to do. So we're going to hit save, and it's going to create a job in the system for this part number at this specific revision as well. That's how we kind of track things in the system, is by part number, revision, and job number. Okay. So what we did, and when I said auto create this, what the system did was created what we call this index. And you can see that right there. And an index for high QA is simply a list of submission documentation, right? That submission information that's available to you. So here is the, I just listed this as like a level 4 PPAP, right? A custom PPAP from your customer says, okay, I need this documentation. However, if you need a different index, that's fine. You click on this little change index button. Now, these are the indexes we have, or I should say I have on my system right here. The one you're looking at is this level 4 PPAP that has these elements in there, and those are the same elements that are in there. But let's say you only have, I need an FAI for this. Okay, great. You can make as many as you want. Actually, let me take a step back. One of the distinct advantages of high QA is the level of configurability in the software itself. Okay. What I mean by that is a lot of other software systems, they'll have one of two ways to do it. They'll say, here's the index it is, or here's the requirements, here's your workflow, here's your whatever. It's kind of set in stone, if you will. And the other side is the customized side. It says, hey, what do you want it to be? We'll custom configure a system however you want. We're kind of unique because we're right in between there to say you can basically generate any type of index that you want. You can see a few of them listed here. This list could be 100 long if you need it to be. It doesn't matter. And the components can be separate for each time as well, for each index. So much so, meaning on the configurability side, that you can have specific document instances for a specific index. Let me say that a different way. Let's say, hypothetically, you do work for GE Aerospace, okay? And GE Aerospace wants you to use their SPC form, with their header on it when you submit your information, hypothetically. Okay, sure. So you could create an index for GE Aerospace and put their specific SPC document in the index. So that way it's auto-populated on the correct form in the correct document, right? So it's that level of configurability that's in the system that's absent in a lot of other systems. But let me show you how some of it ties together, okay? Now we're really going to talk about how information ties together. Let's look at the process flow, for example. If we look at the process flow, we can see that all the information that we just entered in our manufacturing operations when we were in there is already populated in our process flow, right? It's already in there. And that came from our library, which I'll show you that in a little bit. But we can always add processes. We could say, oh, we need to inspect this, and then we're going to stock it and store it in the warehouse. Okay, great. There's our added processes to it. Auto numeration. We have the symbols in there, so you don't have to like click and draw and try to get them in the right spots and all that good stuff that a lot of QEs do. At least I used to do. So all that information is automatically done for you. So let's pause for a second. We're going to talk about getting data back into the system. Okay. There's two ways that we really can get data back into the system. Let's call it an automated way and a manual way. Okay. The manual way is still automated, but we'll get to that in a second. Just so you know, think of it this way, if it runs on software, we can pull it in automatically as a background operation. So from a CMM, a VMM, a Keyence machine, an ARM, a tracker, even like a machine tool probe on a CNC, if that can kick out some type of comma delimited file, we can automatically bring that information directly into HighQA, directly into the database. I'm going to give you an example of what I mean by that. So on my system that you see here, I have this file folder location set up as a listening folder. So inspection manager on my computer is listening to this folder all the time. These are simply 30 pieces of data, or 30 pieces to mimic like a 30-piece run done on a CMM. If I would open sample number 1 here, this is just like a typical CSV common delimited file that would come from your CMM, right? So I'm simply going to copy these and paste them over here. And this is, we have a background. I say background because it happens in the background. There's nothing. Oh, okay, it's gone already. So what happened is we were listening to this location. It saw files hit this location and automatically brought them in. If we go back to the main system, I'm going to go over here to machine sync. Okay, and here are those 30 pieces that were just there. You see sample 30 right there. You see sample 1 and sample 2 right there. And you can see sample 1 is already processing. So it pulls them in automatically and then processes them into the system. Just to let you know, again, no smoke and mirrors going on. I'm going to click over into the parts and into the drawings. And right here, you can see a sample pull down right here. You can see it's already processed number 1 and number 2. I'm going to come back to this later and you'll see all 30 populated in there. Okay. But that's from like an automated measurement system. From a shop floor data acquisition side, we also have a product called Explorer. Because you're still going to have to do your measurements, right? There's always like calipers, mics, height gauges, things like that you need to get into the system. So this is a very lightweight, user-friendly application that's in like Google Chrome, right? It's not web-based, it's browser-based. So keep that in mind. It's not going outside of your network. All right. So if you happen to have like a router or a traveler that goes with your job, you can simply scan that barcode and it pops up with the job. You can also go by gallery search. You can go find the job that you're working on. You can simply grab the job that you're working on here, go into it, nice dashboard, let you know how complete the job is. That's nice for like a management side. Now here, I'd like to also pause and let you know, if you look right here, you see 1, 6, 11, 16. Those are the sample numbers. Those were automatically derived from the sample rate that was in the bill of characteristics. And you see 0 of 1 here. What does that mean? That means only one dimension needs to be measured. So we added the CTQ to one dimension, right? So the CTQ is based on an AQL table. These are the samples that were from the AQL table for that one dimension. So that's why it shows that. Just wanted to let you know that it's not just a document population. It's also doing other things for you. Okay. But now you simply click into the sample you're working on, and now here's your manufacturing operation tab. You can see we're already in the roughing side, and now I can enter data directly into it, right? And here's another element of that cohesive ecosystem, right? Because here you need to select the exact tool that you're using. And since we have the category set as caliper, now it only shows us that list of calipers. So it streamlines it for our shop floor people to be able to enter this data against it. And because it's tied to the gauge management side, we can make sure that they don't enter data from a gauge that's out of calibration, right? So if I select my gauge 002 right here, you can see this is blinking. We support like Bluetooth, wireless, RS-232, however you want to do that, or just typing it in, right? It's very touchscreen friendly. But maybe you need to communicate to them how you want them to measure it. Right down here in our instruction tab, you can see you can have work instructions and gauge instructions directly in here. But we can just enter data. Whoops, go back to the screen itself, 0.5, let's say, and it's real-time feedback from them. So it automatically turns green and toggles to the next one. And by the way, this is dynamic. You can move this around. You can zoom in, zoom out. It's very, very touchscreen friendly and very user friendly. But let's say they need to, if it's like an attribute check, it would look like this. Okay, like for a thread gauge or something, you can hit past. We won't get into it much, but also know that if they happen to enter a bad number, it pops up with a message that makes them confirm it, that it really was bad. All right. Helps with erroneous information from getting into the database. But if it is, you can also populate a non-conformance directly from here. All right. So that way, all your information is captured from your non-conformance, from your data from on-site. Okay. So just wanted to let you know, just to introduce it to you. For the sake of time, we won't go over it now. But just wanted to, oops, helps if I type it in correctly. We do have shop floor data SPC. So this is just simply meant, you can, a lot of our customers have this on like a, a TV on their CNC or something like that to display it. You can track real-time statistics as it's entered. So as it's entered in the system, it's available on your directly on the SPC chart, right? This is just a simple SPC chart, CPK, PPK, all that good stuff. So you can do that as well. But getting back to our submission, so we need to get to our submission package here. So we have our process flow, right? So let's go into our FMEA. So our we're actually going to build the PFMEA right now. So we're going to say next. Now, something to note here. So I used to get dinged every once in a while on an audit for having different information from a PFMEA to a process flow to a control plane, because one would get updated and forget to update everything. That actually can't happen in our system, because if you look right here and right here, we're actually serializing the forms inside the system, so they're linked to them. Okay. So one thing we haven't talked about either are workflows, and we won't touch on it much today for the sake of time. But just know that we have full digital workflows in the system that will track each individual document and submission requirement that needs to be done, and it'll track it digitally through the system. Who's going to fill it out? Who's going to sign it? Who's going to approve it? The workflows also allow for an extraordinary level of configurability. Who do you want? How many steps do you want? Do you want it to go through 23 steps of an approval? You can certainly do that. Do you want to have 17 workflows here? You can certainly do that as well. So it's very, very configurable how many workflows and the steps of the workflow. And here you'd select like the exact people, like, hey, maybe Scott's going to be the one to do it. And you have multiple people, like maybe Joe or Tim can put the data in, but Scott's going to be the approver on it. Could certainly do that. Whatever form you want to use, and that goes back to our custom forms that can be in there, like maybe customer specific forms, your customer specific forms. Okay, so what are we looking at here? We're looking at our automatically generated PFMEA. Now, this is the standard AIEG format. There's really kind of three different formats for the FMEA. The kind of like characteristic driven one that's getting more popular in aerospace. And is it VDL? I think it is VDA, VDL, something like that, for automotive. So we're eventually going to support all of those. Currently, it's the AIG only for the severity, occurrence, and detection, which is still the most widely used, to be honest. But the other ones are going to be supported either by the end of this year or next year. Okay, it is on our roadmap. But this was automatically generated from the information in the library. So what happened is, in the process flow diagram, we noted all of the operations, right? And their linked processes. So then in the library are all of the failure modes for these processes. So that way, when that failure mode, or excuse me, when that process was selected, these failure modes were automatically populated into the system and generated. Okay. But now that they're here, they're part of this unique part record. So you could change things here to say, oh, this is actually really a 6, automatically changes this or recalculates it, automatically updates that. All that information is done for you. And then, of course, any of the part specific actions right over here on the side, responsibility, you can have people here, whatever you'd like to be, or whatever you'd like it to be, excuse me. Another really cool function, and this is kind of across all the forms, is you can have suggestions in here. to where you only have certain things that you allow them to choose from. So it's super helpful on that. All right, so getting back to our index, let's look at our control plan. So in our control plan, very similar. I'm going to go through this quicker than the PFMEA because it's the same process. Okay, and you can actually add people later. Grab that form, hit complete. And so the control plan, what it's doing is it's going to the bill of characteristics, going to the manufacturing operations, tying all that information together, right? The control plan doesn't become a living document. It actually just becomes a static document based on the data from the bill of characteristics and that's already in the database, right? Here was our roughing op. We identified it as a milling group in the manufacturing operations, right? We changed all of our specs by 20 thou. Those carried over. There's our CTQ. Scroll this over a little bit. Whoops, sorry about that. We identified caliper. Sample size is 75 because our sampling frequency for OP10 we changed to 100. All that information is automatically put in, and it can't be different from how you're doing it, right? You're doing it that way, so you set it up that way. Now that information is simply carried over to the document that's updated on the control plan. And you can see the rest is 1 per 20. Here's this one is AQL based because that was our CTQ. Again, all that information was automatically generated from it. Let me pause here for a second and let me show you that library real quick. I keep referring to it, right? So if we go up in our manufacturing tab, here's our process library. So we give you a lot of this information already. This isn't like blank and you have to do everything yourself. All right, so we give you a lot of what traditionally is done, like the manufacturing steps. But this can be your processes, as many as you want, as complicated as you want or whatever. But when we pulled in that milling operation, for example, or the milling process, we pulled in a fabrication step. Why? Because that's what was listed here, right? So this is where you set up the default for it to come in. When we selected the milling up, we brought in these failure modes. So this is like the template where all of that information came from, right? So if we change something here, now it'll be changed for all future times that we bring in that milling operation or milling process. Okay. So this is kind of the library of where all this information is stored. You can even look at all the FMEA templates. Here are all of the processes. And again, this is the traditional AIEG format, severity, occurrence, detection. All this information is populated in the library and where it comes from when it's put onto the PFMEA. Sorry, I almost said control plan. Okay, getting back to our PQP records. So we also have this really cool button right here called Sync Materials and Drawings. If we click on that, what it does is it goes and grabs the balloon print and all of the manufacturing operation prints, brings them into our submission index. But also remember that material we added at the beginning? That is now added in here as a separate line item or a separate category. That's the word I wanted. And the aluminum is in here because we entered it in, right? So here's our aluminum. We're clicking on it. Here's the MMS 123 we added in, our attachment, our material cert. Everything is in there. All we did was click the button to say, hey, include that in our submission documentation. Now from our FAI, or actually let's pause for a second and go to our SBC. So if we go back to our drawings tab, so all of our information is here. Here's those 30 samples that came in, right? We had 2 in there at the beginning and now all 30 are in there. So now if we click on our SBC tab, there's nothing here because we haven't told it that we want to enter any data for SBC, which also is really cool because you don't have to, it's not a traditional SBC software to say, hey, you have to enter the data here, enter the data here, and then calculate it. If you want to run them for 2 years and then go back and see what it ran 2 years ago and compare it to today, the data is already in the database. all you need to do is tell it you want to look at it. And we're going to do that right here. It's very, very simple. All you need to do, this is where we started. So when we first started and ballooned it, right down here, there's a tab we did not click on before called AQL and SBC. And all we're going to do is click on this little box right here that says monitor SBC and hit save. That's it. Okay, I'm going to do that on a few dimensions here. We'll grab 3 of them here just so it looks a little better. And actually, let me grab this one up here. Okay, so we'll grab 4 of them there. Now, if we went to SBC, for those 4 that we calculated or checked on, here's all our information. Here's a run chart, just simple run charts here. All of our capability information on the side, X bar and R charts, histograms, all that information is captured right here. But if we need this as part of our submission package, we're going to go back to our PQP records right here, same place we were before. We're going to click on our SBC report. Okay. And we have, you can have your own SBC report in here if you wanted, or multiple ones. We just have a generic lot inspection report. We're going to say what lot is associated and then what operation. Well, this is certainly the finished part. Include only SBC. We'll check that box and say, all right, now our next step. Then it's the same process as before, right? Hey, oh, and by the way, we set this as a default workflow, right? Maybe you want a different one. Great. Just change it to whatever you want it to be. Very simple, very easy. And now we go into our SBC spot and we hit complete. Now it's taking the data that was automatically put in. Oh, I forgot to change the date. It's not going to populate it, but it's going to take the data that was automatically put in from the CMM and then automatically populate it into our requirements here, right? So I did forget to change the date. I'm not sure if I can do that here for the sake of time. 22, save and reload. Okay. It's recalculating based on that. Essentially, it defaults to today's time and date, so it didn't populate, it didn't update. Now you can see that here they're updated over on the side, and if we scroll down, we can even see, like this one, for example, this was automatically populated from the data that was automatically put in from the CMM, right? Have all of your information, and again, just the idea that you can have this in your system, in your form, your format, however you want it to look. And if we go back to our index, let's click into our FAI. And we'll just use a single, you can use whatever format you want. Again, just configurability of the system. We'll use the standard AS9102. What sample do you want to use for that? Here's our 30 samples. Let's say we want to use sample number 7 for the finished part, because that's where the data was brought in from. And we'll just say next. And you can see there's a lot of options there, partial FAIs, all that good stuff. We support all that. And then for Scott, let's say again, next, complete. And now that information for part number 7 that was automatically populated from the CMM came into the AS9102 report, and now it's readily in the system. Right? You can, anything that's yellow, you can add information. Okay, just type it in. Anything that's not yellow is actually linked from another source of the database itself, right? So we have all of our information. Oh, by the way, we said, oh, here's our aluminum, right? That we put in form 2. It's automatically populated in here. In our form 3, all our information was automatically put in and populated from our CMM that was transferred in. And all our requirements that were in our bill of characteristics that we got when we clicked on auto balloon print, right? All of that information was automatically put in. We do have gauge R&R functionality as well. And essentially that's just a form for us that you can populate. You can grab like feature name. Which one am I grabbing here? I'm gonna, grab that dimension, and then what am I using? Oh, I could use a digital micrometer. Okay. Again, that's nice. That digital micrometer is linked to the measurement tools, right? So if we click next, I'll just click through this one real quick. So what it's doing is it'll build that gauge R&R form. Now it'll have the yellow spaces to where you can enter data for the information from the CMM from all the runs. It defaults to a 3x3x10. However, you can change that as well, like a 2x2x10 if you'd like to. But this 3x3x10 can be, as you enter information, the calculations automatically happen. For the sake of time, I'm not going to do that here, but you'd enter the information in here and in all of these, and then all of your gauge R&R information is automatically updated and regenerated and recalculated as soon as you do it. Okay. So now all of that information is in here, and wanted to point out a couple other things in the few minutes we have left. And that's simply that as you enter through the workflows, your progress will update here. You can also use this as a, let's call it a quasi project management tool. It's not a full project management tool, but you can use it as such by defining dates and assigning responsibilities. So much so that we have notifications set up in the system, like this one right here. You've received this new PQP document to review, right? So we have notifications in the system that would also notify them via email, all digital, right? No paper. So we can have all of this information right here. And when we're done, we would simply say create final package or build final package. It would take all of this information once all of these hit 100%, it would take all this information and then put it into one PDF package for you to be able to submit to your customer. Okay. So that's it in a nutshell. We covered a ton of area today. Thank you so much for your time. Would like to open it now to questions and answers.
All right. Thank you for that, Tim. Before we transition to the Q&A session, I want to remind everyone that this webinar is being recorded, and you'll receive follow-up email with a link to it, so you can revisit this whenever you like. And while we've already received some good questions from the audience, you still have a little time to submit one. Just type it in the question pane at the right of the screen, and we'll do our best to get to it. One person asks, don't know if I missed it, but can you set up global defaults for inspection, i.e. inspect 10% of tolerances greater than plus or minus 0.04, measure 25% of holes in a pattern, etc.?
That's actually on our, so current product, no, that's not available. However, it is on our roadmap. We're getting a lot of like requests for that, especially based on tolerance. Like, hey, can you change the gauge category based on a tolerance? You know, that level of configurability into the system. It is on our roadmap, but just to be very transparent with you, it's not in the current product right now. As far as like gauges go or settings, if we look into our default gauge category, how it's set up as for these different types. So it looks at the type, then put in, like for example, on mine, I had for a linear, put a caliper. So we have that in the system. And then for our categories that we had set up, for example, I had this one set up for customer, and you could set it up maybe for part type or for customer. And these are just defaults. Again, these are just defaults in the system. But for mine, I had set it up at 1/20 here. So maybe you want the default to be something else for measured dimensions. Again, on the roadmap would be like, okay, let's dig into that further, tolerance base and all that good stuff. But we do have some configurability right now.
All right. And can you load data from software into NetInspect automatically?
We do have a transfer from HiQA to NetInspect, yes.
Right. Is your software compatible with Zeiss CMM and Calypso software?
Yes, Calypso actually is one of the main ones. Calypso, PCDMS, Polyworks, even like MeasureMind if you're running an OGP. Essentially, I forgot what they called, like a file table or something like that, that Calypso kicks out. We bring that in automatically. So yes, definitely.
All right. This one is a bit technical. NDT information and instructions in the drawing. How do we get into the APQP and aerospace FAI? Example for radiography, UT, etc. in addition to CMM data?
Okay. So it would need to be a requirement on the print. Now I say that I say that loosely. And what I mean by that is you can add things to the print that are not on the print. And let me show you what I mean by that. So this is the same print we started with, right? Where we can come down here into the bill of characteristics and add a spec for NDT, if you non-destructive testing, if you'd like to, by simply clicking on add, and you can add any information in here. That you would want to have requirements put against, right? So now that it's in here, it would also be available to put data against it from our shop floor data acquisition tool as well. Okay. One other thing to note about that is a lot of times you'll have customers that have maybe a just not NDT spec on here. Ran into this yesterday where they had, it was an OEM and they had their own custom specs. So what we can do, and this is just an example, super quick example. Let's say we have a hardness spec like this, but you want to track something else against it. In this case, we had a customer that wanted to track temperature and time against this hardness spec. We can also do what's called add an extension template that says, okay, for this hardness spec, add these two, temperature and time. So when we hit apply, now that information, even though it wasn't, the spec was on the print, but not the dimensions themselves, the dimensions are now added to the bill of characteristics as a requirement. And those requirements can, if you want them to be, added to the FAI or statistics or whatever you want it to be. It's once it's in the database, you can do anything you want with it.
All right. I'd like to remind people that Effie from HiQA is also answering questions in the chat. So if your question hasn't been answered by Tim, it still might have an answer in the chat. Keep an eye on that. Next one, we often have CMM reports with graphics that can be attached or linked into the HiQA inspection, or better, have those graphics been embedded?
So currently what we do is we're taking the information from, we're a database, right? So it can be attached as a separate attachment, but what we're looking for from the CMM is the actual data itself. I'm not sure if you're talking like Zeiss PyWeb where it's the graphic, or if you're talking maybe like PCDMIS where it has the PDF of, excuse me, of like the tolerance chart or the bullseye for true position. But currently we're looking at the data itself and to get the data in.
For SPC, you select DIM number 2, which include more than 4 different features. How does that work?
Oh, great question. So for dimension number 2, if we look at it right here, just as I mentioned, I clicked on this and then selected monitor SPC, just like you said. However, also keep in mind, there are multiple callouts here. And what you see here is the red one is the active one. So that's the one we're talking about. Like if I select, scroll down right here, now it's on the thread. And if I select AQL and SPC, you can see that it's not monitored. So we actually break those out individually because maybe, why would you want to monitor a pass fail from a thread gauge? But yes, you want to monitor the diameter. So you can actually break those out individually.
If we need to add the name of the certified personnel, including their stamp number, how we go about that?
Oh, absolutely. So if I'm understanding you correctly, on the measurement gauge side from the certification, and I'm hoping I'm answering this right, usually the cert would come in from your certification vendor or calibration lab, if you will, and then we simply include that as an attachment in the database and update the date, so that way you're fully traceable in the system. I hope that's what you meant. If it's not, please let me know.
Can you upload multiple CMM files at once?
Oh, absolutely. I just uploaded 30.
And can you have multiple approvals required at a specific step of the workflow?
It's going to be sequential. So it's one of two things at that point, and let me answer that in a different way. I'm going to pull up the kind of like the back office side right now where the workflows are. You can see them right over here. So in this case, this goes from this person to this person to this person to this person. It is set up sequential. I'm going to answer it one of two ways. You would have you'd have to have multiple steps in there, maybe for the same level of person, maybe quality manager, quality manager, quality manager. Sure, no problem. You could certainly do that. In addition to that, you could have multiple people in that one step. Now, with those multiple people, it would be whatever one person would. It's an or. It's not an and, it's an or. This person or this person or this person can approve it. Whereas if they were in 3 different steps, then it would sequentially go to those 3 different people.
All right. I think that's all the time we have for today's webinar. We hope you found it valuable. Thanks to everyone for attending, and thanks to Tim for the informative presentation and for fielding these questions about the material. If you have any other questions or would like more information, you can reach out directly. So thank you all for joining us, and enjoy the rest of your day.
Thanks, everyone.